Albert Einstein said that mass and energy are different manifestations or representations of the same thing. So, mass is not conserved alone. The amount of mass in the universe is not constant at all times, and neither is the amount of energy. However, the sum of mass and energy together is conserved at all times. He put these ideas into an equation, into E equals mc squared, his very famous equation, where E equals to energy in joules, m is mass in kilograms, and c is the speed of light, which equals to 3 times 10 to the 8th power meters per second. So, energy equals to mass in kilograms times the speed of light squared. And energy could be converted into mass, and mass could be converted into energy. So, when you lose mass, you lose energy. And when you lose energy, you lose a very small amount of mass. A cooling cup of coffee that releases heat energy is losing a very small amount of mass. And this mass is unrecognizable. In fission and fusion, which are nuclear reactions, the total number of nucleons, or protons and neutrons, is constant before and after the reaction. However, the mass before the reaction is different from that after the reaction because energy is lost from the atoms. U, or the atomic mass unit, is a unit of energy which equals to the mass of a proton or a neutron. 1 U gives 931.49 mega electron volts. An electron volt is an energy unit. So, if you have mass in U, you could write the equation E equals mc squared, where E is in joules and m is in kilograms, as E equals 931.49 times mass. Mass here will be in U's, and energy will be in mega electron volts. Of course, you could convert the energy, which is in mega electron volts, into joules. 1 electron volt equals to 1.66 times 10 to the power of negative 19 joules. So again, if you have mass in U, you could find energy in mega electron volts by multiplying the mass in U by 931.49, because this number is the amount of energy that 1 U makes. Of course, electron volts could be converted to joules. Now let's say a car is moving at 5 meters per second and you're observing this car at rest position. To you, the car is moving at 5 meters per second. However, if you are moving at 3 meters per second, the relative velocity between you and the car is 5 minus 3, or 2 meters per second. To you, the car is moving at 2 meters per second, and to the observers inside the car, you are moving at negative 2 meters per second. This is called relative velocity. Relative velocity depends on the frame of reference. So if you are not moving, the car is moving at 5 meters per second. If you are moving, the car is moving at a different velocity. To a person inside the car is not moving because the person is moving at 5 meters per second and the car is moving at 5 meters per second. Relative velocity applies to all objects except for electromagnetic waves, which include visible light. Electromagnetic waves in vacuum are always at 3 times 10 to the 8th power meters per second. So it does not matter whether you're moving or not moving. Light is always at 3 times 10 to the 8th power. This was also a theory of Albert Einstein. It was called the Special Relativity. Einstein's first postulate of special relativity states that speed of light is the same for all frames of reference. So light is always at 3 times 10 to the 8th power meters per second in vacuum. Whether you are moving or are at rest, light always has the same velocity. The second postulate of special relativity states that the speed of light is independent of the speed of a source. That is, if light is coming out of a torch in vacuum, the light is always at 3 times 10 to the 8th power meters per second, whether the torch is at motion or not. 3 times 10 to the 8th power is the speed limit of the universe. Nothing could move faster than light. Einstein got this theory by looking at the equation of velocity. Velocity or speed equals to distance over time. Einstein thought of what it means to measure distance and time. He said that for two observers, the distance light has moved and the time that was measured is different. So, if you divide the difference in the distance by the difference in time, their values will cross each other out, and the speed of light will be the same for both observers. So, for two observers viewing light, the distance moved by light and the time will be different. However, these differences are equal and will cross each other out. At the end, the speed of light will always be 3 times 10 to the 8th power meters per second. And this is Einstein's special relativity. Now, while this might sound weird, it was proved by experimental evidence. As an object approaches the speed of light, that is, if you're riding a rocket and it approaches the speed of light, time will dilate. That is, time will move slower. A watch will have its arms moving slower. Length contracts at the direction of motion. That is, if you are moving in this direction, this length will become shorter. However, the width will not change. So only length in the direction of motion will become shorter. Mass increases. So, as an object approaches the speed of light, time dilates, length contracts, and mass increases. So, time becomes slower, length becomes shorter, and mass increases. When you reach the speed of light, you will become infinite. You will not be matter anymore. Matter cannot move at such a high speed. That's all for today. Subscribe, like, and achieve more. Thank you.